Chapter 1, Video 3, and this video just attempts to tidy up sections that were just glossed over or omitted from videos 1 and 2. So the 3 videos together should give quite a comprehensive coverage of the whole chapter. So the first thing to revisit is the idea of constructors. In video 1 we talked about constructors, we talked about a default constructor, and also the fact that you can define extra constructors, and we've got one in the animal class here that takes the name. So I'm just going to put the default one back in as well, because remember we lose the default constructor if we define any other constructors, but let's put the default one back in. So we've now got 2 constructors in this class. One thing that's often tested on the exam is to show the signature of a constructor. The thing to remember is it doesn't have a return type. It's public animal in both cases, and then any parameters you want to pass in. It doesn't have a return type because it doesn't make sense to have a return type. A constructor is there to construct an object and put it into memory, so it doesn't make sense to have any kind of return type. But if we do put one in there, if we put void, and that's usually the one they try and catch us out on, that all compiles fine in the animal class, but the thing to realise is that is not a constructor anymore, it's a method. It's a method because it's got a return type. It happens to be a method that has the name animal, and it looks like a constructor, but it's not. We can do the same here. These all compile fine in the animal class, but if we now look at the zoo class, this is now failing because it's saying it doesn't. It's basically saying it doesn't have a constructor that only takes a string as an argument. And we look here at first glance, it looks, oh yes, it looks like we do, but again, it's because it's got a return type. So we have to take that out and out of this one, and know that those are now valid constructors. They don't have a return type. Another thing, going back to variables, we looked at the different types of primitives, variables in video 2. What you can do as of Java 7, it was introduced, is you can put underscores in there when you have very large numbers, just to break them up to make them look more visible. So you can do that, for example. It just makes it look easier to look at. The thing to realise, you can't have underscores the first thing. You can't have that, and you can't. So that doesn't compile. It's gone red. So you can't have it as the first character, and you can't have it as the last one. Like that. Doesn't like that either. Typically, you do it in the same way as you do a comma when you actually write numbers to separate them into 3s, and you can't have them either sides of a decimal like that. So you can't have that. It doesn't like that or that. So underscores can be used, but not at the beginning or end or around a decimal point. So we can do it like that. And the other thing is about import statements. So let's put some redundant import statements in. java.lang.wildcard. So that would import anything in the java.lang package, but we get that anyway by default. So that's redundant. Let's put another one in. Import java.security. .wildcard, so anything in the Java security package. Now those are fine, they won't cause anything not to compile, but they're completely redundant. So it doesn't matter that you've got them, it's just untidy. So it's best to get rid of redundant imports. What you can do it in IntelliJ is Control Alt and O, and it'll just remove any redundant inputs for you. Incidentally, another useful shortcut in IntelliJ is Control Alt and L. And if you see that, I've put the indentation of this variable is wrong. It should be aligned with these ones. So if I do Control Alt and L, it puts it back into position like that. So just another useful IntelliJ shortcut. We talked about variable scope. Obviously class variables have the highest scope, then instance variables, then local variables. But just even within local variables, we need to be aware of a certain concept. We can actually, even we said that local variables are only visible within their method, which is true, but even there we have to be careful, because we can have various blocks of code even within a method. So let's put an if statement here. Now we don't cover if statements till chapter 2, but just to illustrate an example, I'll put one in. and I'll put a boolean check scope equals true. This is just contriving an example here to use. Then if check scope equals true, which it is because we've set it to true, then we're going to do some extra logic. So an if statement has its own bracketing here, and we're going to define a new variable in there. We'll find another int equals 6, and then down here we'll print out the value of it. Just copy and paste the value of it, and we can't, it doesn't recognize it. That's because this another int variable is defined within this block of code, within these curly brackets. So even within a method, it might not be visible everywhere. You have to check where it is in terms of its own curly brackets. You can have multiple levels of indentation there, so you have to put it only where it's visible. So that would be okay here, like that. That's the basic structure of an if statement. We'll look at that in chapter 2. Another thing to cover is when you run Java from the command line. So we already introduced class A and class B. I've enhanced class B a bit here to print class A's name as it did before in video 1, but also to print out what is the value of args0, in other words the first argument in the program commands. So what we do, let's get our command line prompt again and recompile package B, and now what we can do is we can run package B with the Java keyword, so it's package B dot class B, but this time we're going to pass a command line argument in, and we can do as many as we want, so 1, 2, 3, etc. We're actually passing 4 in there, so they follow the class. So it's Java, then the class, then as many command line arguments as you want. So let's just run that, and this time it prints out class A's name is Charlie, as it was before. Class B program argument 1 is hello, which is the first one we printed there. Just to tidy that up, if we didn't pass something in there, so if we just did that, it'll fail. Array index out of bounds exception 0. It's basically saying that you've tried to get something out of this args array, but there's nothing in there. So before we do that, let's just check for it. So again, we can use an if statement here. We can use if, and arrays have a property called length. Dot length is less than 1. Then we're going to do a system out print line here. I'm just going to copy it from here. At least one argument must be supplied, like that. And then we'll do system.exit. This system exit is a way of just quitting the program. Exit, and we'll do 1. 0 it tends to be when it's executed. Fine. And I'll just, because we're in an editor here, I have to physically get the indentation right. So that's that. If the args.length is less than 1, now that's a conditional operator which we'll meet in chapter 2, then it will print this to the screen and exit the program. Otherwise it will print it. So now let's just save that and recompile it. So that's recompiling package B there. And now let's run it again, but this time we won't pass any arguments in. And it's given us our message, at least one argument must be supplied. That's better than throwing an exception to the user. So now we'll call it again with our argument. And what we can do as well, just to bring it on the screen so you can see it, if we want to put more than one word, we can put it in quotes like that. So hi there. Otherwise it would recognise that as 2. So hi there, there it is. Otherwise, if we didn't put that, it would only get the first one. Hi. So hi there forces it to use it like that. So the other thing to cover is covered in this class here. Integers by default are in decimal, because we do by default work in decimal, but if you prefix an integer with a 0, it puts it into base 8 octal. If you prefix an integer with OX, 0x, it puts it into base 16 hexadecimal. And if you do 0b, it creates it as a binary. So all these look like they're 11, 11, 11, 11, but one of them is a decimal, one's an octal, one's a hexadecimal, and one's a binary. So let's print out the values of that. So here we have the output of that program. We've created a new instance of it, and then we're referencing those variables through the instance and dot. And you can see they're all different values. They all look like 11 on the screen, but only the decimal one actually is 11. The one in octal is actually 9. One hexadecimal is 17, and the one in binary is actually 3.